In 1908, something exploded over Siberia with the force of 185 Hiroshima bombs. Trees were flattened for 800 square miles. But there was no crater, no debris, no explanation. The shock waves circled the Earth twice, and for 3 days, the night sky across Europe glowed so bright you could read a newspaper at midnight. Scientists still don't know what happened. And that's just the beginning. Right now, at this very moment, there are phenomena occurring in our universe that violate every law of physics we've ever written. Things that shouldn't exist. Events that make our smartest minds go silent. And some of them happen right here on Earth. Before the end of this video, you're going to see footage of an experiment that shouldn't be possible. You'll learn about a day when gravity stopped working the way it should. You'll discover why one of Einstein's colleagues died believing we live inside a hollow Earth, and why the math actually supported him. And you'll find out about the signal we received from space that was so precise, so impossibly structured, that the scientist who found it named it after a joke, because the alternative was too disturbing to consider. But first, we need to talk about what happened in the sky above Hessdalen, Norway, where the laws of physics have been breaking down every single night for over 40 years. Physics is supposed to be reliable. It's the foundation of reality. The rules that govern everything from falling apples to collapsing stars. But there are moments, specific points in history, where those rules simply stopped applying, where reality glitched. And what's terrifying isn't just that these things happened, it's that they're still happening. And we're no closer to understanding why. The Hessdalen lights. In a remote valley in central Norway, there are lights that shouldn't exist. Not metaphorically, literally. The Hessdalen lights are glowing orbs of plasma that appear almost every night, floating through the valley, sometimes stationary, sometimes moving at impossible speeds. They've been witnessed and recorded since at least the 1930s, but the phenomenon intensified in the 1980s when locals reported seeing them up to 20 times per week. Here's where it gets strange. Scientists actually studied this. They set up monitoring stations with magnetometers, cameras, and radar equipment. The lights showed up. They always do. But the data made no sense. These aren't ball lightning. They're not drones. They're not reflected headlights or swamp gas. The electromagnetic readings suggest they're made of ionized gas, but there's no energy source. No combustion. No explanation for how they form or why they stay coherent for hours at a time. One physicist measured their temperature at over 500 degrees Celsius, while they emitted almost no heat to the surrounding air. That violates thermodynamics. Another team captured footage of a light splitting into 2 separate orbs, which then orbited each other before merging again. Plasma doesn't do that. It doesn't have memory. It doesn't have structure. And yet here's the disturbing part. The lights seem to react to observation. Multiple researchers have reported that when they point equipment directly at the phenomenon, it changes behavior, moves away, or moves closer. We'll come back to that idea, that concept of observation changing reality, because it shows up again in a much darker context later in this list. But for now, just remember this. There's a valley in Norway where the rules of plasma physics don't apply, and nobody knows why. The WOW signal. On August 15, 1977, a radio telescope in Ohio detected something from space. A signal so powerful, so precisely tuned, that the astronomer monitoring the data grabbed a red pen and wrote, "Wow," in the margin. That name stuck. The WOW signal lasted 72 seconds, peaked at a frequency of 1420 MHz, which is the exact frequency hydrogen emits, and came from the direction of Sagittarius. Here's what breaks physics. Natural phenomena don't create narrowband radio signals. They create noise spread across frequencies. This was focused, deliberate. The signal's intensity suggested it came from a transmitter more powerful than anything humanity has ever built. And then it just stopped. We've pointed every available telescope back at that spot in the sky hundreds of times. Nothing. Silence. But here's where it gets worse. In 2012, a researcher analyzed the original data using modern technology and found something the 1970s computers missed. The signal had structure. Variations in intensity that weren't random. They looked like modulation, like information. And the mathematics of the pattern? They matched what you'd expect from a signal that had traveled through interstellar space for thousands of years, adjusting for the Doppler effect of planetary motion. So either we detected a cosmic coincidence so unlikely that it shouldn't happen once in the lifetime of the universe, or we received a message, and whoever sent it had technology that makes ours look like smoke signals. The reason this breaks physics isn't the signal itself. It's what it implies about intelligence, technology, and how common it might be in a universe where we've never seen any other evidence of it. The Fermi paradox says advanced civilizations should be everywhere. The wow signal says maybe they are. They're just not talking anymore. Keep that thought. We'll return to it. The Tunguska event. Let's go back to Siberia, 1908. June 30th, at 7:17 in the morning. A blast of light appeared in the sky so bright that a man 40 miles away felt heat on his face. A shockwave followed that knocked him off his porch. Seismic stations across Europe registered the impact. Eyewitness reports described a pillar of fire that reached into the sky, followed by a black mushroom cloud. And then, silence. For nearly 20 years, nobody investigated. Russia was in chaos. By the time scientists reached the site, the evidence had degraded. But what they found defied explanation. Over 80 million trees flattened in a radial pattern from a central point. Except at the central point, there was no crater, no meteorite fragments, no impact residue. Trees at ground zero were still standing, charred and stripped of branches, like telephone poles. The explosion had come from above them, not below. The current scientific consensus is that a meteor or comet exploded in the atmosphere before impact. An airburst. But here's the problem. The physics don't work. For an airburst to flatten 800 square miles of forest, the object would need to be massive and traveling at hypersonic speeds. That object would leave a debris trail. It would create chemical signatures in the soil and ice cores. We've found none. The Tunguska site has been analyzed with modern equipment dozens of times. Some teams reported elevated levels of iridium, which is common in asteroids. Others found nothing. Some detected magnetic anomalies. Others didn't. And then there's the trees. Dendrochronology studies showed that trees which survived the blast had a massive growth spike in the following years. They grew faster than they should have, like they'd been exposed to radiation, but there was no radiation. Not the kind we can measure. One researcher found microscopic spheres of metallic glass embedded in the tree resin, a material that only forms under intense heat and pressure, but with an isotopic composition that doesn't match any known meteorite type. What exploded over Tunguska? We still don't know. And that should terrify you, because if a rock from space did this, we have no way of predicting or stopping the next one. And if it wasn't a rock, then what was it? Cyril Hoskin's experiment. You've probably never heard of Cyril Hoskin, and there's a reason for that. In 1956, this British physicist conducted an experiment so disturbing that his university destroyed the records and refused to speak about it publicly. We only know the details because Hoskin published an abstract in an obscure journal before his death. He was trying to measure consciousness. His hypothesis was simple. If consciousness has mass, even an infinitesimal amount, then a dying organism should lose weight at the moment of death that can't be explained by breath or fluid loss. He'd been inspired by the discredited 1907 experiment by Duncan McDougall, who claimed the human soul weighs 21 grams. Hoskin wanted to be more precise. He built a containment system with organisms sealed in airtight glass, placed on scales sensitive to micrograms, monitored continuously. The first trials used insects, then mice. And according to his notes, every single organism lost a measurable amount of weight at the moment of biological death. Not grams, micrograms, but consistent, repeatable. And here's where physics breaks. The weight loss happened instantaneously, not gradually. One moment the scale read one value, the next moment it dropped. No transition, like something had simply vanished. The disturbing part isn't the measurement. It's what happened when Hoskin tried to scale up. He proposed using larger animals. The ethics committee refused. Hoskin continued anyway, in secret. His last journal entry described an experiment with a chimpanzee, and the weight loss was proportional to brain mass. He calculated that a human being would lose approximately 18 to 23 grams. The university shut him down, confiscated his equipment, and Hoskin disappeared from academic record. Some say he suffered a mental breakdown. Others say he continued his work independently until his death in 1991. But here's the question nobody wants to ask. If consciousness has mass, where does it go? We're going to return to that question, because the answer might be hidden in something called the quantum Zeno effect, which we'll get to. But it's point number 8, so stay with me. The London hammer. In 1936, a couple hiking near London, Texas, found a rock with a piece of wood sticking out of it. They cracked it open. Inside was a hammer. A metal hammerhead with a wooden handle, encased in solid limestone. The rock was sent for analysis. The limestone dated to the Cretaceous period, over 100 million years old. Now, before you roll your eyes, let's be clear. Most out-of-place artifacts are hoaxes or misidentifications. But the London hammer has been studied extensively, and the results are problematic. The metal composition is 96% iron, 2.6% chlorine, and 0.74% sulfur. That ratio doesn't match any known manufacturing process, ancient or modern. The iron shows almost no corrosion, even in areas where the rock was broken away. Modern steel rusts. This doesn't. Skeptics argue the hammer was dropped in a creek bed, and minerals rapidly formed around it, creating a concretion, not true limestone. That's possible, but it doesn't explain the metallurgy. It doesn't explain why the wood handle has partially petrified with the cellular structure still visible. Petrification takes thousands of years minimum, and it doesn't explain the chlorine. Chlorine in iron makes it brittle. It's not used in toolmaking, but there's one context where high chlorine iron occurs naturally, in meteorites. Specifically, in a type called hexahedrite, which is almost pure iron nickel and contains chlorine compounds. So either this hammer was made from meteor metal by an unknown ancient culture with advanced metallurgy, or the dating is wrong, or something much stranger is happening with how we understand fossilization and geological time. And here's the kicker. There are dozens of similar artifacts. Nails in coal, metallic spheres in Precambrian rock, a screw embedded in a stone dated to 300 million years ago. Mainstream science dismisses them all as contamination or misinterpretation. But the physics of mineral formation says these things shouldn't be possible. So either our understanding of geology is incomplete, or time doesn't work the way we think it does. Hold that thought, because point number 9 is going to make you question whether the past is even fixed. The EMDRIV. In the early 2000s, a British engineer named Roger Shire announced he'd built a device that violated the laws of physics. He called it the M-Drive. It's a cone-shaped cavity that you pump microwaves into, and somehow, impossibly, it produces thrust. No propellant, no exhaust, just movement. This breaks Newton's third law. For every action, there's an equal and opposite reaction. Rockets work by throwing mass out the back. The M-Drive doesn't throw anything. It's a sealed container. And yet when independent teams tested it, including NASA's EagleWorks laboratory, they measured thrust. Small amounts, just micronewtons, but consistent and repeatable. NASA published a peer-reviewed paper in 2016 confirming the effect. The scientific community lost its mind. Some called it measurement error. Others said it was interacting with Earth's magnetic field. But here's the problem. They tested it in a vacuum. They shielded it from electromagnetic interference. They oriented it in different directions. The thrust remained, always in the same direction relative to the device, not the Earth. So what's happening? The leading theory is that it's pushing against quantum vacuum fluctuations. Space isn't actually empty. At the quantum level, it's seething with virtual particles that pop into existence and annihilate constantly. If the M-Drive is somehow interacting with that, then it's not violating Newton's third law. It's pushing against something we can't see. But that raises a darker question. If you can push against the quantum vacuum, can you pull on it? Can you manipulate it? And if space itself is made of something with structure and properties, then what happens if you damage it? Can you tear a hole in reality? We're going to come back to that, because there's an experiment from 1943 that allegedly did exactly that. Ancient nuclear reactors. In 1972, French scientists analyzing uranium from a mine in Gabon, West Africa, found something impossible. The uranium isotope ratio was wrong. Natural uranium is 0.720% U-235. This sample was 0.717%. That sounds like a tiny undergone fission dot difference, but in nuclear physics, it's enormous. It means the U-235 had already been depleted. It had already Further investigation revealed 16 sites in the Oklo region where natural nuclear fission had occurred approximately 1.7 billion years ago. Natural reactors. They'd been active for hundreds of thousands of years, moderating themselves with groundwater, operating in cycles. It's the only known natural fission reactor on Earth, and the physics are so precise it's almost unbelievable. For a natural reactor to form, you need uranium or water as a moderator and a specific geological configuration. The odds are astronomical. And yet here it is. Except some researchers have pointed out something disturbing. The reactor geometry at Oklo is too efficient. The placement of uranium, the spacing, the way water channels were configured, it all looks designed. Not by humans, obviously. This predates multicellular life, but designed nonetheless. One physicist calculated that if the fine structure constant, one of the fundamental constants of the universe, had been different by even 1% at the time these reactors formed, they wouldn't have worked. But they did work. Perfectly. For millennia. And the waste they produced, the isotopes left behind, match exactly what a modern nuclear reactor produces. We found plutonium-239. That isotope doesn't occur in nature. It only forms in reactors. So either the laws of physics were slightly different 1.7 billion years ago, which has terrifying implications for cosmology, or these weren't entirely natural. And if nature can build a nuclear reactor by accident, what else has it built? What else is buried under our feet, operating by principles we haven't discovered yet? The quantum Zeno effect. In quantum mechanics, there's a phenomenon so bizarre that even physicists who work with it daily find it unsettling. It's called the quantum Zeno effect, named after Zeno's paradox. Here's how it works. If you observe a quantum system continuously, it can't change. An unstable particle that should decay will not decay as long as you're measuring it. Observation literally freezes reality. This has been demonstrated in laboratories repeatedly. In one experiment, scientists took a collection of radioactive atoms that should decay over time. Left alone, they decayed as expected. But when observed constantly with measurement equipment, the decay rate slowed. And with frequent enough observation, it stopped almost entirely. Let that sink in. The act of measurement prevents change. Not because the measurement equipment interferes physically, but because observation itself is a physical act in quantum mechanics. The universe behaves differently when it's being watched. And here's where it connects back to Cyril Hoskin's experiment. If consciousness is tied to observation, and observation affects reality at the quantum level, then conscious observation might have physical consequences we don't understand. Some physicists have gone further. They've proposed that consciousness might be what collapses the quantum wave function, turning probability into reality. If that's true, then your awareness is literally creating the universe around you moment by moment. And if you stop observing something, does it stop existing? There are experiments suggesting this might be true. In 2015, a team demonstrated that they could change the past behavior of a photon by choosing how to observe it in the present. The photon's history rearranged itself based on future measurement. Cause and effect broke down. Time stopped being linear. And if time isn't linear, if the past can be changed by the present, then everything you remember might be a reconstruction. Reality might be rewriting itself constantly, and you'd never know that. The Philadelphia experiment. Now we enter territory that most scientists won't touch publicly. In October 1943, the U.S. Navy allegedly conducted an experiment to make a ship invisible to radar. The USS Eldridge was fitted with massive electromagnetic generators based on unified field theory. When activated, according to witnesses, the ship didn't just disappear from radar. It vanished. Completely. Teleported from Philadelphia to Norfolk, Virginia, over 200 miles away, then reappeared. The official Navy position is that this never happened. It's a hoax. But here's the problem. The conspiracy theory comes from Carl Allen, a man with no credibility, but the science behind it comes from real physics. Einstein spent the last decades. The official Navy position is that this never happened. It's a hoax. But here's the problem. The conspiracy theory comes from Carl Allen, a man with no credibility, but the science behind it comes from real physics. Einstein spent the last decades of his life trying to unify electromagnetism and gravity. He never succeeded publicly. But what if he did privately? If you generate a powerful enough rotating magnetic field, theory suggests you could warp spacetime locally. You'd create a bubble where the geometry of space is bent. Inside that bubble, different laws apply. You could, theoretically, move without crossing the space in between. That's the Alcubierre drive concept, proposed seriously in 1994. The Philadelphia experiment allegedly happened in 1943. Witnesses who came forward described crew members fused with the metal of the ship, men who went insane, others who could walk through walls or spontaneously catch fire. These are the symptoms of matter existing in superposition, of quantum states collapsing incorrectly. If the experiment did happen, and if it did involve warping spacetime, then the ship and crew would have been subjected to conditions where physics, as we know it, didn't apply. There's no hard evidence. But there's also the Montauk Project, the alleged continuation of this research, and the persistent rumors that the military has technology decades ahead of public science. If they achieved spacetime manipulation in 1943, what can they do now? You'll notice I'm not dismissing this outright. That's because point number 10 makes the Philadelphia experiment seem tamed at the cosmic microwave background anomaly. This is the big one. The cosmic microwave background is the afterglow of the Big Bang. It's the oldest light in the universe, a faint radiation that fills all of space. It should be almost perfectly uniform, with tiny random fluctuations. And it is, except for one thing. In 2005, scientists analyzing data from the WMAP satellite found an anomaly, a pattern. The fluctuations in the CMB weren't random. They were aligned. There's an axis running through the universe, a preferred direction, that cosmologists have nicknamed the axis of evil. This shouldn't exist. The universe shouldn't have a direction. The laws of physics should be the same everywhere, isotropic. But they're not. Follow-up observations with the Planck satellite confirmed it. The alignment is real. And it's not small. We're talking about structures in the fabric of space-time itself that span the entire observable universe, all pointing the same way. Some scientists think it's a flaw in our instruments. But we've checked with multiple satellites, multiple methods. The axis is there. Here's the disturbing part. If the universe has a preferred direction, it might mean we're inside something. A larger structure. The universe might not be infinite. It might have boundaries, edges, and outside. And if it has an outside, then what's out there? What is our universe embedded in? Some cosmologists have proposed we're in a simulation, and the axis of evil is a rendering artifact, like a pixel grid at cosmic scale. Others think we're in a bubble universe, one of many, and the axis points toward another bubble. Another universe pressing against ours. But there's a darker interpretation. If space has a direction, then relativity breaks down. Einstein's theories only work if space is isotropic. If it's not, then everything we've built on top of relativity, all of modern physics, is an approximation. A model that works locally but fails at cosmic scale. And here's what keeps physicists awake at night. We only understand 5% of the universe. The rest is dark matter and dark energy, labels for things we can't see and don't understand. What if dark matter isn't matter? What if it's the structure we're embedded in, and we're only now beginning to see its shape? Let's connect this. The Hessdalen lights react to observation. The quantum Zeno effect says observation changes reality. The wow signal might be a message from a civilization that understood this and used it. The M drive pushes against quantum vacuum, the same substrate that might explain dark energy. Ancient nuclear reactors that shouldn't exist, operating by laws that might have been different in the past. A cosmic axis that says the universe has structure we can't see. What if all of these aren't separate mysteries? What if they're glimpses of the same underlying truth? That reality is not what we think it is. That the laws of physics aren't laws at all, but local conditions, like weather. And sometimes the weather breaks down. Every anomaly, every impossible event, might be a crack in the facade. A moment where the real rules, the deeper rules, become visible. And if that's true, then the question isn't, why do these things happen? The question is, what's on the other side? There's a reason mainstream science doesn't talk about these things. Not because they're not real. The data exists. The measurements are there. But because accepting them means accepting that we don't understand reality. That our models are incomplete. That the universe is stranger and more hostile to comprehension than we want to admit. And maybe that's the point. Maybe the universe isn't here to be understood. Maybe the moments when physics breaks down aren't anomalies. Maybe they're reminders that underneath the equations and the theories and the certainty, there's something else, something we're not equipped to perceive. So the next time you see something that doesn't make sense, something that shouldn't be possible, don't dismiss it. Because the universe has already shown us, again and again, that impossible is just a word we use for things we haven't explained yet. And some things were never meant to be explained.